Hello, this video is designed to show you how to use an R package and save yourself some extra time. I'm going to assume that you have downloaded and installed R, that you've downloaded and installed TinR, that you have saved wing.csv, population.csv into a folder on your desktop, and that you have opened TinR and gone to File, Open, and then you've opened Script 2. So you're starting out with a screen that looks like this. So the first thing that you need to do is make sure that your R terminal is switched on. There are two ways of doing this. You can either go up here to R on the tool ribbon, or you can go up here to the little green screen and click it, or you can click it over here. So I'm going to be lazy and just click the green screen, and up starts my R terminal. Okay, so it's just basically reading through, making sure it knows what it's doing. Okay, so let's make sure that I know what my working directory is. Now that the R terminal is switched on, you'll notice that the send lines have turned bright green, so everything's ready to go. So I'm going to take my cursor to line 5. It says get working directory, send line. It says that's where my working directory is right now. That's not where I want it to be. I don't want it to read out of my Dropbox. I'd like it to read off of my desktop, so I'm going to put the pathway of my desktop folder up here, change it to data analysis folders, and now I want it to read out the file called wing. So I send that information to it. Now, just to make sure that the data from wing is inside of the R terminal's brain, I'm going to type wing and send that to it, and as you can see, here comes the data. Male and female wing length and the return individuals on each. So if I was going to do some statistical analysis on this data, one of the first steps would be to ask whether or not my data is normally distributed. And there are many ways of going about this. What I like to do is to run some tests of normality. To save myself a whole bunch of time, I'm going to use installed packages. So one way to ask the R terminal what you've installed is to just type in installed packages and then send that line in. What I want to show you though is how to go about finding and installing a package that you have determined could be useful to you. So for example, stats or Ggplot or nortest. So we're going to load nortest in here. What you'll do is you'll go up to this little icon that is a package. It's a package that has a ribbon tied around it, and you'll click that once and you get a variety of options. So I want to bring in a new package, so I'm going to go down here to new and I will left click that. I'm just going to give it a second, see if anything happens. The R terminal is looking through a whole bunch of lists of packages. As you can see, there are thousands of them. We'll wait a little longer. I can tell something's happening because my cursor is blinking on and off. Alright, so I want to install a package. So what I'm going to do is click install. Give this a second. And here's a list of potential packages for me to install. Now, which one you will choose depends on what particular tasks you're wanting to be able to perform. If you want to learn more about the commonly used R packages or a list of all of the R packages, you can go on to the R for Stats website and look through them. So what I'm going to do here is I'm going to scroll all the way down until I find nortest. As you can see, there are hundreds and thousands of these things. N-O-R. Not non-test, not norm. Test, I need nortest. Okay, so I click OK. So as you can see, it says it's just downloaded NOR-test. And then here now I need to make sure that I load NOR-test, so I click on load. It gives me a set of tests that, packages that are currently in the memory of my computer, and here's NOR-test, that's the one that I need to load. So you need to make sure your package is loaded. It's done this, it gives us a little warning message. It says it was built under a different version of R. I'm okay with that. I want to make sure that I've loaded stats. One of my favorites. I'm going to make sure that's loaded. And I want to load Ggplot. Say OK to that one. And here we go. Alright, so it's just giving me warnings that these were built under different versions of R. I'm not particularly worried about those at this point. So you can load whatever tests you want. Now each one of these packages will have a list of functions. In order to figure out what those functions are and how to call them, you'll want to go to the documentation that's found on the R website. So let's say we want to go the next step. So let's go back to Wing and have a look at that data. Okay, so here's the data. Very happy with that. And now I want to do my first test. So the NOR-test package has got 5 different ways to test your data for normality, and each one's a little bit different. So basically what you'll do is you will write out the name of the function that you want. You say, I'm calling the data from file Wing, and you have to specify which column you're looking at. So I'll be looking at males, for example, and you send that line into R's brain, and out will come your data. So it says your Shapiro test. Here's a Shapiro-Wilk normality test. Your data came from file Wing, column male. Your W value is 0.8 and your P value is 0.003. So it says this is the P value is the chance that the sample comes from a normal distribution. So the lower the value, the smaller the chance. So if the P value is lower than 0.05, then you would say that the sample deviates from normality. So that's one way of doing the test. You could also do an Anderson-Darling test on that same data. You can do a Lilly-Forrest test. So I need to change the column name. So this is the male. So here's your data for that. So you can go through different versions of these tests, just calling them. You can, instead of doing the males, you can change the column name to female and do a Shapiro-Wilk test on the female's data. Compare that, so that's not significantly different from normal. So here you've got data where one column is normally distributed and the other column is not normally distributed, so that will tell you that you're probably going to be using a non-parametric test if you're comparing males and females. You might want to do a test for variance. This is a test that comes from the stats package. So we're going to test for variance of males and females. So add that data in here, and so out comes your data on the other side. So you can do a t-test, and you can ask if the wing length on males is significantly different than wing length on females. Now this would be a t-test, and you should only really do a t-test if you have got normally distributed data for both of your columns, and we don't, so we shouldn't use a t-test. I'm going to skip to the non-parametric t-test, which is the Van-Whitney or the Wilcoxon test, and let's run that. Male, female. Okay, got that coded in nicely, so press send, and here it says your Wilcoxon test. With continuity correction, the data is the male versus the female on the file Wing. Your W value is 9.85, your P value is very, very small. So the alternative hypothesis is true. That means that your two sets of data are not equal to each other. because the null hypothesis would be that there is no difference between them. The alternative hypothesis is that there is a difference between your two sets of data. So we would say that the alternative hypothesis is true or supported in that there is a difference between male and female wing size. So there you have it, the very first way of loading up packages and using some of the functions within them.